The web cache or the cache is the concept that we know that's used to speed up the loading of any web page. However, have you ever wondered how a cached page could expose users' private data, such as API keys and passwords, without them even knowing? In this video, I'm going to walk you through a hands-on lab from PortSwigger Academy, demonstrating how attackers can trick a caching mechanism into storing and exposing sensitive user-specific contents. Also, if you're preparing for Burp Suite Certified Practitioner or even any other advanced web hacking certification, this is the kind of video you want to watch. So let's get started. So click on Academy and then navigate to Web Cache Deception. From here, you can see all the breakdown of all the materials. So to get started, basically, first, let's go over what is the cache. Before we get into web cache deception, let's understand what is cache. So basically, as illustrated here, the cache sits between the user, which is you, and the website you're trying to access. So what happens first when you send a request to a website, you're basically first going through the cache. Okay, so the cache looks into your request, and if there is a copy of the response, or if you have visited the page before, the cache will return the response back to you. This basically happens most of the time to static resources. Static resources are those static web pages that do not change often. So let's get back to the user and the website. However, if the cache does not contain a copy of the response, or if the user is visiting the page for the first time, what happens then? The request will directly go to the website. The website then will send the response to the user, but before the response gets to the user, it first gets to the cache. The cache stores the response of the website and then returns the copy of the response to the user, so that the user, if they visit or if they decide to visit the page again, the cache will have a readily available copy that it returns to the user, thus speeding up the delivery of web pages. And that's what's known as the content delivery network. All right, now having understand the cache, let's go back to web deception attack. So how it works. So we have the attacker sitting in the middle here, and we have a victim, and there is the origin server, and we have the cache. Okay, now remember that we previously said that the cache stores static contents, static web pages, not dynamic contents. Dynamic contents change often and contain JavaScripts, session information, cookies, username, passwords. This is called dynamic content. The cache that we talked about stores static content, static pages. Okay, pages that do not change often, such as this one, for example. Okay, the goal in web deception attack is to trick the cache into storing dynamic content. So that's the first thing to learn about web deception attack. In the web deception attack, we want the cache to store dynamic content. Okay, now why we want the cache to store dynamic contents is because we want to access sensitive information. Basically, usernames, passwords, session information, cookies are stored in the dynamic contents of web pages. They are not stored in static web pages such as this one. This is a static web page. Okay, mostly static web page. It doesn't contain sensitive information. However, responses or requests sent to dynamic pages, such as login pages, response of the login page is dynamic. So basically, cache do not store or doesn't store the response of dynamic requests. In a deception attack, because we want to access the contents of dynamic response, we want the cache to store the dynamic contents. Okay, so the attacker then crafts a URL. Okay, much like we craft a malicious payload using MSF Venom, the attacker crafts a malicious URL. The attacker sends the URL to the victim. Okay, the example here is a GET request to a JavaScript file. JavaScript represents a dynamic content. Okay, so basically the attacker sends the URL to the victim. Now, when the victim visits the URL, okay, the rules of caching get enforced. So we go back to caching. The user sends the request to the server or to the origin server. The cache sits in the middle. Okay, it looks whether it has a copy of the response. Let's go back. So the victim sends a request to the web page containing the profile script. Now what happens? The cache looks into the request. It doesn't contain the response, because we said earlier the cache does not store the response or does not store the response of dynamic requests. So it forwards the request or the GET request of the user to the origin server. The origin server processes the request and returns a response. The response then is sent back to the cache, and usually without any interception from the cache to the user, but it does not get stored. That's the thing. Any other static elements get stored. However, the dynamic response to dynamic elements do not get stored. Now, with the attacker sending a malicious URL, what happens? The cache will be tricked into storing a copy of the dynamic response. And then, because now the cache, contrary to all the rules, it now contains a copy of the dynamic response sent by the user about the profile page. It could contain session information, cookies. So now the attacker, to access the session or the cookies, they will send a request to the same. They will click on the same URL that they sent previously to the victim. Once they click on the URL, what happens? The cache now contains a copy of the response, right? We said earlier that caches, if they do not contain a copy of the response, they store the sent response from the server before they forward the cache to the user. So here it happens because the cache previously processed the response from the user and now stored the dynamic response because it's a malicious URL. Now the attacker can now access the contents of the dynamic response by visiting the same malicious URL, because now the contents or the dynamic response is stored in the cache. So now the attacker was able to manipulate the rules of the cache. The cache usually stores static contents, static pages. Because the attacker was able to craft a URL, the URL tricked the cache to store the dynamic response sent to the user, and now the attacker, by visiting the same URL, they will retrieve the contents of the response from the cache instead of the origin server. That's how it works. Now let's talk about the steps that we need to take in order to exploit a web cache deception attack. And here it is not poisoning, it is deception attack. Okay, and they are actually very different. Okay, so the first step, we want to remember that in web cache deception attack, we want to access the dynamic contents of the dynamic responses. So the first step is to identify the target endpoint. We want to identify an origin server, it could be a website, that handles and processes dynamic contents, such as session, cookies, and other identifiable or other sensitive information. The next, so having identified the endpoint or the origin server, next we want to identify a weakness, or what we call it a discrepancy, in how the origin server and the cache process URLs. Now remember that caches process URLs based on query parameters, based on delimiters, based on paths, based on access files. All of these are actually rules that determine how cache processes the requested pages. So basically, we want to identify a weakness in how the cache and origin server handle the requests. Identifying the weakness will lead us to crafting a malicious URL, and then the malicious URL is sent directly to the user, so that the user clicks on the URL, accesses the page, and then the response is stored back into the cache. Once the response is stored in the cache, now the attacker can access the same URL. Actually, the same URL will be accessed by the attacker, and then the cache will render the dynamic contents, or the cache copy of the dynamic contents. Okay, so in PortSwigger, it's perfectly explained how path mapping discrepancy occur. So basically, web servers or origin servers handle requests using two methods. First, we have the traditional URL mapping, and the other one is the REST style URLs. So basically, when you request a resource, such as this one, so this is a request to a page named resource, which is an HTML page. If an origin server uses the traditional URL mapping, what happens is the server will evaluate the URL literally to a directory on the file system. So if there is a directory that literally matches this structure, the file will be returned to the user, and the user will be able to access the page. So here we have the domain name example.com, and then we have /path/in/file system. If the server uses traditional URL mapping, this is the path that should be physically present on the server, Linux or Windows, it doesn't matter. And then if the path exists, it will look in the path or the directory whether the file resource.html exists. If it exists, the web server now returns a copy of the page to the cache and then to the server. That's the traditional URL mapping. That's how you access web pages, basically using the traditional URL mapping method. Next, we have servers or origin servers that use the REST style URLs. Here, the path is not treated as a physical directory that must be present on the server in order for the user to access the URL. What happens here, we use what's called as the RESTful APIs. So basically here, this is an example. A user accessing a page /path/resource parameter1 parameter2. So when the RESTful API is used, what happens, the path here /path/resource is treated as an endpoint representing a resource, basically an API endpoint. And parameter 1 and parameter 2 are URL parameters that are processed by the server to return the result of the request. So we do not look into the physical file system. We use RESTful APIs to process the requests. These are two methods used to map URLs. So we mentioned that previously that when we want to exploit web cache deception, we want to find a weakness in how the origin server and the cache processes URLs. Now we have determined what are the methods used to process these URLs. Now we want to find the weakness. So basically, this is an example here. You see the example, user accessing or tries to access a profile for a user named or for a user whose ID or whatever 123. And at the end we have a request, or the URL ends with a CSS file. So with the traditional method of processing URLs or mapping URLs, we have a server that looks exactly for a file that exists under such file system in the physical server. If it exists, it will return the response. If it is not, the user will receive 404. However, in REST style URL, the user, when accessing this URL, they will access a profile page for the user 123, and the CSS file will be ignored. Okay, because remember that in REST style URLs, we use APIs to process the API endpoints to process the URLs and return the response back to the user. We do not rely on physical file systems. So here the file is ignored. Now, remember that the response is received first by the cache, as we mentioned earlier. The response is returned from the site back into the cache, and then in return, the cache returns the response back to the user. Let's look at the cache, how the cache processes the responses. So here we have the cache. You can see the cache. Now, also the cache uses both traditional and REST style URLs. Now, the discrepancy happens when the origin server uses a method that is completely different from the method used by the cache. A cache that uses traditional URL mapping, okay, and origin server uses REST style URLs is called discrepancy. And it is illustrated here. For example, let's say that the server uses REST style URLs, which means that this URL will not be, or the path here will not be treated as a physical directory that must exist on the server. It will use the endpoint, basically return the URL, or the user /123/profile will return the web page of the user whose ID or whose username is 123. And then the CSS file will be ignored by the origin server. However, if the cache uses the traditional URL mapping, when the response is returned by the user using this URL, the cache will interpret the request literally as a file that must exist on the server, and therefore it will store the contents on its cache. Because you see, the cache now will think that this is a complete file that should be stored on its cache. Remember that cache stores static contents. CSS, usually it is treated as a static. It depends on the cache rules. However, generally speaking, CSS files, JavaScript files, HTML files are seen as, in most cache content delivery networks, they are treated as static resources. So when the cache uses traditional URL mapping, it treats this URL as a static resource. Therefore, it will store the response of this request, despite the fact that the response of this request contains the profile information of the user, which is deemed as dynamic. Therefore, now the cache stores dynamic contents. And now the attacker, if the attacker is able to craft a malicious URL, they will be able to retrieve the contents of the dynamic response, meaning the profile information, session, and cookies information. Now, here we go. We have a lab exploiting path mapping for web cache deception. To start the lab, just click on Access the lab and take a note of the credentials, because we're going to need them to log into the account. And of course, there's a solution here if you get stuck. But we're not going to look at the solution now. We're just going to try it ourselves. So basically, this is the URL of the lab. And when you're ready to submit the solution, or basically click on the button here. And when you're ready to exploit or send exploit to the victim, you can click on Go to Exploit Server. It will open this link. In this link, do not modify the file and head sections. Just locate the body section, and here you write the response. So basically in the body, it will be the malicious URL that we will send to the victim. Okay, so now I opened the links in the virtual lab, and of course I got Burp Suite up and running. So first I'm gonna log into the account using the credentials assigned here. So this is the username and this is the password. So to solve the lab, find the API key for the user Carlos. So there are API keys that are tied to every account. Probably once we log into one account, we will be greeted or we will be able to see the API key for that account. Now, our job is to find the API key of Carlos. So let's log in. And as expected, you see we have the API key, username is Weiner, and this is your API key. Okay, now remember that the URL here is this. So basically, that's the URL here. You see in the browser URL bar, you see that the request to slash my account. Let's have a look at this request in Burp Suite. So Burp Suite is up and running, proxy is on, going to refresh the page, or first associate the browser with Burp and refresh. Now we're gonna have a look or send the request to the repeater and disable the intercept. Okay, great. Now let's go back to Burp, to the repeater, and have a look at the request. Remember here, we want to understand how the origin server and the cache server handle the URL. So that's the GET request to slash my account to display the account details. That's the host or the origin server. You see we have other details tied to the request, such as the cookie, the user agent, and other information about the cache. Let's see if there is information about the cache. Set fetch mode, X cache. So there are no information about the cache. If we send this request to the server, we see X from options, same origin, but we do not see any indications of a cache mechanism here. Okay, going back, let's say we want to update the email to, or maybe let's log out. So basically, let's go back to the proxy. It is off. Let's now log out and log back in. Take a look at the history here. So that's the recent request we sent before. And that's another request where we see a different session cookie. And here we're looking to find information about the cache. So basically, if there is a cache mechanism, it will be shown in the header. The cache keys, whether it is a miss or whether it is a hit, it will be shown in the request. That's what I'm looking for here. I want to see how the cache handles the requests. So we're going to have to look for this through the requests displayed in the history, but we do not see any. All right, that's fine. Let's go back to Burp and enable the intercept, and then the credentials. Now, before we click login, the request should be intercepted with the intercept button here. We have a request to this. Let's forward this for now. And now, let's log in. So that's the request to the Academy login. Let's have a look at any cache headers. Okay, there are no cache headers. We're gonna send the request forward. And there is a request to slash my account. Okay, we're gonna send this as well. Okay, now go back to the history. Let's now resend the request to the repeater. Okay, now what we need to do here, we're gonna have to modify the URL. So basically, if we write my account slash maybe profile, or let's say, yeah, it could be profile.css. So why I'm doing this? Because remember that I want to test how the origin server and the cache server handle a URL that ends with an extension such as CSS, or it could be JavaScript. So if we send this request, you see we have 302 found. So that request is not cache. You see cache control. We have now information about the cache. Cache control 30 and x cache equals to miss, which means the page here does not get cached. If we resend the request, it will change, as you can see, the cache x cache now header changed to hit, which means now the request has been cached. But however, this request is not useful because it returned 3 or 2. Let's now try something such as, or a different extension, profile.js. And here we have a cache miss, which means this page is not cached. If we resend the request, now it changed to cache hit. X cache hit means now the page has been cached. But we want a valid response to be able to demonstrate the exploit. We're going to have to get a 200 HTTP response code. To do that, it looks like we're going to have to log in again. So let's go back to the proxy. And from here, we're going to log out and click my account. Log back in. The proxy is on now. Log in. Okay, gonna forward. So that's the request to we want, the request to slash my account. I'll highlight this, send to repeater. And now we get a valid response. All right. Now let's try this. So slash, as we spoke earlier, let's try with files with the extension CSS or JS. Maybe try thm.css. All right, so now we have a cache, x cache equals to miss, which means this page is not cached, okay? If we resend the request, now it changed to x-cache equal to hit, which means now the page is cached. Remember that this page includes sensitive information, which happens to be the API key. So now we know that the cache stores the contents of this page. However, remember that this is a request to display the account information. And this is supposed to be a page that is considered or stores dynamic contents, the API key that we spotted earlier. So we expect that the cache does not store such contents. However, what we saw here is that the X cache changed from miss into hit when we changed or when we added an extension or a file with an extension, which means that the cache is configured to store requests. All requests are responses to static files, such as files or CSS files and JS files. So now we know how the cache handles the request and the responses, and now we know that the cache stores requests to CSS files and JavaScript files. So now if we craft a malicious URL and send it to the victim using this path, okay, but of course we're going to use a different file. Okay, so now we're going to go to the lab, click on go to exploit server, and from here we're going to send the request to the victim. The idea is we want to get the victim to visit the page. Once the victim visits the page, they will be sent the response. The response will contain their API key. Now, if I visit the page, okay, what's going to happen is I will be able to see the API key of the user because the X cache will be changed from miss to hit. Okay, now let's have a look. Copy this. And let's see here. Yeah. Okay, so we paste this, but probably we're going to have to copy the full URL. So we're going to be back here, and that's the URL. Let's copy this. Go back to exploit server, and from here, paste it. So slash my account. So we're going to change THM CSS to something like http.css because this page has already been cached by the requests we have sent, right? Now that's the full URL. But remember, you want this to be inside script or JavaScript. So we're going to use script. And from here, close the JavaScript tag. And you don't want data to be aware that they are opening this link. So we're going to use window.location. Now, once you delivered exploit to victim, okay, we can go back, visit the same page, okay? Instead of THM, we're going to type http.css. Now, I expect this page to be already cached because now the victim has clicked on the link or visited the page through the window location, and now the cache stores the contents of this page. The contents of this page from the user perspective is the page that contains their API key. And now given that the cache stores the request for the CSS files or to the CSS files, now if I resend the request, I will be able to see the API key. So resend. And this is the API key. Let's have a look. If this API key is different from the ones of the user. Let's go back. That's my API key. Okay, let's try this in the browser. So /http.css. And it's still Winer. Okay. Let's go back to the exploit server and have a look at view exploit. View the log. Okay, let's go back, and maybe we can use another request to using a JavaScript maybe. So JavaScript would work. So change this to GS, http.js. Okay, now we deliver this to the victim. Okay, back to the browser, use GS instead. And now we get the response. We get the API key. So in that case, instead of CSS, you could use JavaScript. All right, so that was it. I'm going to try my best to solve these labs and publish them in later videos. But for now, that was web cache reception in PortSwigger Academy. Thank you for watching.